Hi, welcome to another set of video notes. Today we are moving on to how to graph and solve quadratic inequalities. Now you think, well, we've graphed and we've solved and we've done quadratic. Oh no, inequalities. Remember, that's going to be things like less than, greater than, less than or equal to, greater than or equal to. Okay, so I thought it might help if we kind of reviewed how we used to do it when we had a line. And so I gave you an equation like maybe y equals 2x plus 3. Went up to the y-intercept, that was 3. Went up 2 and over 1 for the slope. Oh, but it wouldn't be equals, silly Mrs. Roth, because it would be an inequality. So say it was less than. We know it's going to go through those 2 points. Do we want dotted or solid? And all the people said dotted. So we put in that dotted line. And then we have to decide whether we need to shade above or below. And remember, we used to talk about take a test point like 0. Will 0, 0 work in this particular equation? Well, I don't know. Put in 0 for y, 0 for x. What is 2 times 0? That's just 0 plus 3. 0 plus 3 is 3. Hey, is 0 less than 3? It is. It works. We want to cover it up. So we shade below. We got to the point that we said, let's just cheat. If it's less than, it's going to be below the line, and you were done. Okay? Well, now we're going to step it up. We've learned to graph something even cooler than just a plain old boring line. We've moved on to parabolas, to curves. So, if we're doing a quadratic inequality, the steps are almost the same because first we graph it. Now, I've given you some hints how we graph. Remember, today we're only going to be working in standard form. So the axis is opposite of b over 2a. We plug that in to get the y for the vertex. We pick the y-intercept. We'll review all this. But once again, decide dotted or solid. Decide shade. And today we really do have to pick a point. So that's why it's good that you practice. So, without any further ado, we're going to move on and do some examples. Your homework or your exercises. We're going to do some practicing. Does it satisfy the inequality? Then we're going to pick some graphs. Then we're going to actually graph. Okay? So not as many different types of problems as what the book shows. Okay? So we're going to move on to our first example. This is a quadratic because it has the square term. Chances are we're probably going to have 2 solutions or 2 places it crosses the x-axis. First thing, when you graph, think way back. This is a great review for the beginning of the chapter. Graphing standard. Oh yes, you've got to find A, B, and C. A is 1, B is 2, and C is -8. Okay? You need to find the axis of symmetry, and that is the opposite of B. So in this case, -2. 2 times 1 is 2. What is -2 divided by 2? -1. So I can put my little symmetry line right here at -1. Yay. All right, now what do I do? Oh yes, I have to plug that into the equation to get y. So -1 squared plus 2 times -1 minus 8. What is -1 squared? Well, that's 1. What is 2 times -1? -2. -8. Okay, and so we get 1 minus 2 minus 8, that's -9. So my vertex is actually -1, -9. Didn't go far enough. So here's my vertex. Okay, now we need to find another point. I could pick a number and plug it in, or we can look at what C is. C is -8. So our y-intercept is 0, -8. We're at 0, go down to -8, and then you get to reflect it. Okay, so I know that it's generally going to go through there. The question is, dotted or solid? Well, greater than, dotted. So you can just kind of start dotting. Okay. And then we have to decide shading. So I'm going to pick the point 0, 0, because that's just a nice one, even though I'm way far away from it. It's easy to calculate. So is 0 greater than 0 squared plus 2 times 0 minus 8? Okay. 0 is greater than negative 8. That's true. So anything inside the parabola gets shaded. Okay? And you are going to have to do those test points because we don't have a cute little, oh, greater than do this, less than do this. It depends on what the sign is here and everything else. Sorry. But yeah, and sometimes I'm just going to give you a graph and you have to pick it. You know, you won't have to graph it yourself. Let's try one more time. We've got a new example, still in standard form, still a quadratic. So this one's a little funkier. We have a is negative 1. We have b is negative 4. Oh no, what do we do for c? Oh wait, it's 0. Okay, so we're going to go ahead and find the axis. Once again, the axis is the opposite of this, which is 4 all over 2 times negative 1. Now look at that, 2 negatives, funky. 4 divided by negative 2 is negative 2, so that's where we draw our dotted line. Do you think it's always going to have a negative axis of symmetry? Okay, so we're going to plug that in, and we've got the opposite of negative 2 squared minus 4 times negative 2. So what is negative 2 squared? It's 4. Take the opposite, that's negative 4. Negative 4 times negative 2 is 8, and we've got 4. So our line is negative 2, 4. So over 2 and up 4. Okay? Now, we can pick a point on either side, or we can just look and say, well, c is 0. The y-intercept is just going to be at 0, 0. So we know we've got this point, and reflected across, we've got this point. Hey, I just changed the problem. Did you notice? Just to give you something different. Now this one is less than or equal to dotted or solid. Oh, this time it's solid. Very good. So we make our nice solid line like normal. Okay. Now, I don't think you want to do 0, 0 because we're already there. I think I'm going to do 1, 1 because that should be pretty easy. So we've got 1 less than or equal to the opposite of 1 squared minus 4 times 1. So let's see, what is 1 squared? 1, and the opposite of that is negative. Negative 4 times 1 is negative 4. What is negative 4 minus 1? Why, negative 5, Mrs. Roth. So 1 is less than or equal to negative 5? No, because I'd rather have $1 than be $5 in debt. So 1, 1 doesn't work, so we don't want to shade outside it. Oh, guess what? We get to shade inside the parabola again. Okay, so once again, what you're going to practice is plugging in a coordinate pair and see if it satisfies it, picking which graph it should be, and then actual graphing. So I will see you in class and we'll practice. Bye.